Awesome. Great. Thank you for coming, everybody. I'm Arijit Mukherji. I'm going to talk about monitoring that monitors the monitors of the monitors. And I'm sure a lot of you are wondering, what the hell does that mean? So let me have the big reveal first. We're obviously talking about Caribbean cannibals, right? And so if you're here to understand why, what the topic meant, you can go now. But I apologize for the joke. But somebody smarter than me told me that if you start a talk, set the level low enough that it only gets better after the fact. So that's what I'm gunning for. But seriously, though, I'm going to talk about alert fatigue, alert noise, and getting that right alert with the right level of noisiness, so to speak. Because I'm sure it's a problem for a lot of you out there. Anybody else have a problem with alert noise or alert fatigue? Yeah, I see some hands. So really the problem is we're going to get notified when something significant has happened. We don't want to get notified when insignificant things happen. And we don't want to miss any notification when something important is going on. So that's fundamentally a problem. We want to achieve that Goldilocks zone. And typically, we tend to look at application and infrastructure metrics or various other signals that we're getting from our applications infrastructure to get these alerts, right? But they are not always successful in giving us that right amount of alert level, so to speak, right? And so other approaches can be useful. And I'm going to explain over this talk a personal experience about something that we tried to solve a specific alerting problem that we had to sort of emphasize a more general point, right? In my case, it was about using social signals. So humans are, are in organizations, they're emitting signals. Can we use some of those to sort of monitor my applications and infrastructure? It's so weird as it may sound. And luckily, this involves metrics and PagerDuty and chatops and Lambda and all the cool stuff out there. So it's good for interest, so to speak. A little bit about me. I'm CTO at SignalFx. I've been there with the company since the beginning. I've been doing monitoring for a long time, more than 10 years now. I was at Facebook early on, again, working on their metric system called ODS. I've had different roles related to monitoring over the years. And I also like bad jokes, as will be apparent. Just bear with me. The next few slides are going to be cooler because my marketing team made it. So what is SignalFx? SignalFx is a metrics-based SaaS. We provide cloud monitoring and operational intelligence. The way to think about it, there's a few things that are special about us or different about us. One is scale and integration. So we are very broad. We can monitor lots of your different clouds, containers, applications, infrastructure, what have you. We're also very scalable. We're able to handle a lot of data volume, as is the case in modern environments. We do real-time analytics. So we had the only streaming real-time analytics-based solution for metrics that it's out there. For us, real-time means seconds. So between the arrival of a signal or data point to your chart or alert getting updated is about 2 to 3 seconds, depending on the data. So that's what we mean by real-time. And obviously, analytics is important. We provide intelligent alerting so that some of the stuff that I'm going to talk about later to make monitoring complex environments simpler. So what's the problem that sort of we tried to sort of solve? As a manager in the organization, I wanted to know if there is something significant brewing in SignalFx. It's deliberately a little vague, but from my point of view, it makes sense, right? So I'm not an operator of any service specifically. I'm not interested in whether a particular server is having a problem or not. As a manager or as a leader, I want to know if something critical or a problem is brewing. Why? Because obviously I need to know. I have a lot of experience within the company. Maybe I can help short-circuit the remediation process. Or maybe I can help with the decision making to sort of make the remediation go faster, right? And I don't necessarily want to know after a problem has happened because then it's kind of late. I would like to know when things are brewing potentially. So it's a little bit vague, but it was a real use case for me, and that's what I wanted to sort of go about doing. And clearly, I don't want to get woken up too often or woken up less often. I don't want to miss important things happening. And what I found was it was way harder to implement something like this. It's much easier to implement something more specific to a specific host or a service. And partly what to blame is the very complex environment that we deal with nowadays. So we are no longer in monolithic world. We have clouds, containers, microservices, loosely coupled systems. It really makes the job of monitoring more complex. And the other fact that makes things worse is we are also moving much faster. We have sometimes weekly or sometimes more frequent pushes and whatnot. So we are moving very fast. So all of these things make monitoring our systems harder. And I don't think that's something isolated to SignalFx. I'm sure many of you are in similar situations. So how does SignalFx look like under the covers? Again, it's nothing unique. We are in the public clouds, multi-AZ replication. We use microservices in a polyglot environment, 25 to 30 different microservices, Java, Go, and a bunch of other languages. Of course, we are containerized. We run Docker containers. And heavy use of open source, right? So again, I'm thinking that none of this must be very unique. For operations, again, CI/CD, GitHub, Jenkins for automation. We deploy, as I mentioned, once a week at least or more frequently. And the important thing here is we use for chatops, we use Slack, right? So that's where much of the collaboration happens between the engineers. How do we monitor it? Obviously, we monitor it with SignalFx because we are a monitoring company. And for us, sort of the foundation is obviously metrics, because metrics are very actionable. So they are one of those things where you can view them, you can alert on them. They don't give you the specific detail about what exception happened, but they give you a sense for how things are going, sort of like the dials on an aircraft, for example, right? We use that heavily. We collect metrics from all our applications, all of our infrastructure, by clouds, cloud services. We use to build dashboards at various levels to sort of view what's going on. We use metric-based alerts to tell us when something is wrong. For example, whether an application is performing well, whether a host is having a CPU issue, or even like for business metrics, right? Notifications, obviously, we use PagerDuty. And then for collaboration, we use chatops. And one of the things I'm going to mention here that's sort of important for this talk is that we use a specific Slack channel, because Slack can get very noisy. It can be many, many, many different channels. So where do you go for the real deal, so to speak? So in our case, we have decided to standardize on a channel we call it outage. And that's where any site issue gets discussed by the engineers. That's our convention. And I'm pretty sure something like this is probably standard in many of your organizations too. For forensics, which is understanding details about what a specific problem happened when our metrics gives us an alert, we use obviously logs. In our case, we use the elk stack, right? Sounds familiar to most of you here, right? So let's go back to the problem. So as I said, I want to be notified when there's something significant going on. I don't want to get woken up too often for things that at my level, I don't care about. And I don't want to get woken up less often, because if I'm not aware of what's going on with the site, I'm going to get fired, right? Again, I want to reach that Goldilocks zone. Some other observations is obviously to do something like this, you cannot depend on like a human to come and wake you up. It's not you cannot make it somebody else's problem, right? I cannot say, hey, engineer X, as part of your run book, you need to wake up the CTO when something serious is going on. That is not a scalable approach. That's not the right way to do it. So the answer was obviously something automated. That's something where I would subscribe to some sort of alerts. But the problem is, which alerts are those? Because I don't care about all the nitty-gritty details. Which alerts are those? And even if I am able to find the right set, how do I keep it up to date? Because again, my environment is changing, new alerts and detectors are getting created all the time. That's a challenge, right? And in spite of some of the best practices that we used, the things tended to be very, very noisy. So I was actually getting woken up much more often than I would have liked. And what were some of the reasons behind it, and what were some of the things we did, or some of the best practices that one can follow? The first problem is that there are just too many things to monitor in these sort of modern environments. What do I mean by that? Just the number of sheer compute instances that nowadays we have to deal with in our new sort of modern infrastructures is far, far bigger than what they used to be, right? Instead of my monoliths and large servers, I have these Amazon VMs, and I have containers, I have pods, I have cloud services, I have, I don't know, like so many different things. I have serverless, lambdas, and whatnot. The number of things is just exploding. And thanks to microservices now, like we are shrinking the service into smaller chunks that are now running on many more instances. If you want to monitor them individually, like say container X or server Y is working well or not, that's going to be very, very noisy, and that's exactly what happened. A common way and a smart way to deal with this is obviously you don't monitor individuals, you monitor populations, right? You do that with analytics. The idea is that you, instead of, let's say, looking at every instance of a large microservice running on tens or hundreds of instances, why can't I look at aggregate metrics across that to see if the service is healthy? Because isn't that what we care about more than the individual? So here are some examples. So for example, if I'm tracking latency across my microservice, maybe again tens or hundreds or thousands of instances, maybe I look at the P99 latency because that is very indicative of the customer's experience too, in some sense, right? So if things are fine, nowadays systems are meant to handle some amount of failure, so why should I care about individuals? That could be an excellent way to monitor a service. Others are, for things like resources like CPUs, you could monitor the average to see, how the whole tier is doing. Or, for things like errors, you might want to sum them up across a population to see how things are doing. And here's, for example, an example of a chart where this really tracks the various percentiles, like, P50, P90, max, so on, across a population. And the idea is you could set your alert to be based on one of these percentiles, right? But that is easier said than done. The problem one runs into when monitoring services is the services tend to behave intractably sometimes. Like they behave in mysterious ways, like you two said in a song. What is normal? What is normal for a service? If you wanted to tell me that, set an alert on, the CPU of service X, what is the right number? Typically, traditionally people have been using static thresholds, and static thresholds are famously bad for situations like this. Because what happens is things change all the time, right? Things are changing all the time. If I push code, well, maybe I made some performance improvements where now the CPU behaves differently. Do I have to go and now change all my alerts? That doesn't make sense to me. Secondly, most services nowadays, any consumer-facing service will have cyclical patterns. Maybe they have, busy Mondays and, weekends maybe are light. What's the right threshold that works across all of these days? There's usually not a good answer to that, right? Another one is longer-term trends. Let's say you're this hot startup which is getting increasing usage from your customers. Well, some of the metrics are going to keep trending up, again, making static thresholds hard to devise, or you have to do a lot of work to sort of maintain them. And wait, it gets better. Nowadays, multi-cloud is a thing, right? So we are deploying into multiple different clouds and environments. Think about it, a GCP instance probably does not behave the same as an Amazon instance. Now do I have to set up different alerts, try to tweak things differently? This thing just doesn't work. And the right way to deal with situations like this is that you have to get away from static. You have to start using more data science, right? So the idea is, why can't we alert on patterns, right? So what do I mean by that? To use algorithmically generated thresholds, right? So they require less care and feeding because they are algorithmically generated. There's no human whose job is to go and keep them up to date all the time. And they can really, really work. So here's some examples of what I mean by that. One is, let's say, the cyclical patterns. So, as I mentioned, there are certain metrics that could, like, number of customer visits or web page loads that can go up and down all the time. Well, you could have a cyclical anomaly detector which looks at the same time over the last, let's say, n different cycles and determines whether now is worse compared to the last n. That sounds smarter, and the good thing about this is it also changes. So weekends tend to be light, so if weekends continue to be light, it's not going to fire an alert for you unnecessarily. Another example is, population outliers. So, well, I don't know what the average CPU across my servers are supposed to be, but maybe I know that they're supposed to be about the same, and if there's a few that are behaving odd, maybe a particular server is under duress, maybe I can find out. So maybe I can find the outliers within a population, again, algorithmically, and that's going to tell me if there's something that needs my attention or not. Another example is trending. So databases, for example, they use a lot of disk, and disk at some point may run out, and which may cause a catastrophic problem. Well, if I could see the trend or the overall trend of my disk usage and see where it's going, maybe I could set an alert which says 7 days before something like that is going to happen, let me know. Because frankly, in a situation like this, knowing after the fact is not great. I want to know before the fact so that I have time to react, right? So these are various approaches one can use to sort of get higher quality, higher signal alerts. But that still doesn't solve all the problems. I call this picture, Tim Cook's worst nightmare. But in general, what's happening is, because of our loosely coupled environment, we actually have too many microservices. So even if you are going to be monitoring individual microservices to say, you know what, I'm getting better, I'm going higher up the stack, there are just too many of them. For example, as I mentioned, in SignalFx, there are more than 20, actually there's almost 30 plus different microservices, and I'm sure that might be common among your environments, right? So again, it's still too many things to monitor, right? And as I mentioned, the reason this is happening is, we are moving to loosely coupled, right? And these things are operated independently too, right? And so, as I mentioned, alert volume continues to be high. So what can one do about that? Well, you could say, well, since I'm going up the stack, let me go one level further. Why do I want to monitor microservices individually? Why can't I monitor overall, like, performance of the service? Why can't I combine metrics or different types of metrics together to provide that higher order signal? What do I mean by that? So for example, let's say I have page loads that are happening. Well, maybe that's correlated with the number of active users on the site, right? So page loads by itself is hard to measure, but maybe the number of page loads that happen over time based on the number of users that are logged in, that should be constant. And if there's a sudden dip in it, that sounds dangerous because perhaps my site is having an issue, right? So that could be one way for me to monitor something that's a little bit more higher level. Another is, again, as similar, API errors, but as a percentage of the number of API calls that are made. So here we are sort of combining different types of metrics together to sort of get a higher level signal, which is perhaps easier to monitor, more indicative of, again, the user's experience on the site. This is the third one, is something that actually one of our customers do. Every time they push code, and they're also in a microservices environment, they actually calculate what's called a health score by looking at each individual microservice, looking at the key performance indicators for those, and combining them together to create like a score. And they use that to determine whether this is green or a red. If it's a red, they're going to roll back first and investigate later, right? And they're able to do that quickly using analytics. So these are examples of sort of going higher level. So we used all of this, and still it continued to be, at least for my situation, still a little bit noisy, because many of the principles I talked about, like, they really, really help, but it's very hard to be solely dependent on any one of them, right? And that's what happened. So in terms of, let's go over what did I try to sort of notify myself, as opposed to certainly for my specific use case, and how was my experience. The first thing I tried was, well, subscribe to critical alerts. Critical alerts obviously are critical. They're showing me something that's important. That's probably the best way for me to go. As I mentioned earlier, I did not want to hand draw a list of specific alerts that I would like to get, because that's hard to maintain. Instead, I just went with the quality. If it's a critical alert, I probably want to know. As you might guess, it was very, very noisy, because monitoring is also, there's different strokes for different folks. My needs are different from the needs of somebody that's, again, operating a service, or a person that's operating a server or a cloud service, because they want to know things in much finer detail. What is critical for them may not be critical for me, but there's no way for me to sort of make the distinction. So critical alerts tended up to, being noisy. I thought, well, I'm going to get escalated. So when things get escalated, that's when I'm going to know. Well, not everything gets escalated if they're sort of getting fixed. And secondly, I'm not always sort of in the loop, or somebody has to remember to escalate to me and so on. That really didn't work. So I thought, well, statuspage.io notifications. But that's obviously too bad. It's too late. By the time status page got updated, I should have been awake and involved, right? So that's clearly not the right way to get notified, right? Then, well, the last thing that I tried was, well, let's look at Slack. I remember I mentioned that we use the /outage channel to discuss any sort of issues related to the service. Lurking on that seemed to be a good idea, right? So that's what I started doing. I said, you know what, my phone, wake me up when something's abuzz in outage. But as you would guess, it's also very, very noisy. People chat there all the time, even for the minor things, which may be potential issues. But if a server fails, somebody's going to go and fix it. I really don't need to know about it. The other problem is, one of the things we found in Slack is, in order to have a conversation in chatops, you need to have the context. Without the context, I cannot be discussing a bunch of stuff. So what that means is, some of our PagerDuty notifications go to Slack. Well, again, that means noisy, right? And so that's what happened. So the question is, how do I get rid of all these false positives, right? So how do I solve this problem? And the answer was to sort of, again, as the cliche goes, think outside the box. And in this case, outside the box are some humans. So the insight was, let's look at social signals. And there's a reason for it, right? So in my case, again, my requirement is a little bit fuzzy. But frankly, I'm a human, and there are other humans who care exactly about the kind of things that I'm doing. So they know we haven't reached the days of Skynet yet, right? So human intelligence is smarter. So they are interested in the kind of things that I'm interested in, right? And guess what? Our engineers are obviously involved with the site. They are collaborating when issues happen. Well, that gives us a sign that perhaps by monitoring their collaboration, maybe something can be done. So maybe there's a recipe that uses social signals to solve this problem, right? And so that's kind of what we experimented with. What we said was, let's have, in our case, services are sending all these metrics to our platform, the metrics platform, and then we have all these detectors that are raising all these alerts, which are getting notified to PagerDuty, and that's going to Slack, and people are collaborating on it. Can we monitor that human activity, right? And that's what we ended up doing, experimenting with. So the way we measured it is, we used Lambda, an AWS Lambda, which uses APIs that Slack provides to go and query all the messages at some particular periodicity, and then it classifies those messages, not even necessarily by the text of the content of it, just by the source, like who said, is it a bot sourced message or is it a human message, right? Classify them, publish these as metrics back to the platform, right? And then the rest is more or less easy. If I have some metrics which says, here's how many messages came, here's how many came from humans, these are the humans that are talking, you can set up some detectors which says, based on these metrics to say, alert me if something significant is going on. So in my case, what I defined after some trial and error as significant was if 3 or more people are collaborating for 5 or 10 minutes, that seems to be a sign that it's not a minor thing where just 1 or 2 people just chatted back and forth and solved the problem. Obviously, it's not a bot-oriented message because I'm ignoring those at this point. But if 3 people come in, that means 3 is a crowd. There's something is going on, right? So that ended being my strategy. And if you want to, again, see this in slow motion, here's how it goes. Our infra and apps are producing metrics, which are going to SignalFx, which is raising alerts, going through PagerDuty back to Slack. Humans are collaborating on Slack. And then the stuff that we added below is, we had a AWS schedule function that's triggering a Lambda. The Lambda uses Slack APIs, again, fetches more metrics, sends back to SignalFx. We raise a different set of alerts. These are now social alerts based on human behavior that goes back and notifies me. And the alert, I'm alert and alerted in the sense that I'm not waking up too often, and I'm notified when interesting things happen. So you might be wondering, how well does this work, right? It actually works very, very well. In my case, the false positives went significantly down to the point that I'm woken up very, very rarely when something like that happened. But more important than that, the cases where I do want to get involved, it almost invariably I do get notified. Because again, anything that's even a significant problem will probably have more than 2 engineers, in this case, involved and collaborating. And so that ended up working very, very well. And the other thing about this is that, like a lot of times, I get notified even when there is no alert. Like people will notice things. They're like, hey, this chart looks odd. Maybe there's no alerting set up for it yet. People will start collaborating, and again, these are potential issues that are brewing. These are, again, in my case, exactly the kind of things that I want to hear about or I want to get notified about, right? And so it worked really, really well. So it was sort of an eye-opener in some sense, and now I really depend on it, and some of our other executives do too. So in terms of takeaways, so what did we learn from all of this? First is obviously, our environments are becoming complex. Monitoring these complex environments is a complex problem, right? And this leads to alert fatigue, right? Because even if you go and if you don't have the monitoring, obviously you're not getting woken up, that's bad. But even if you set up too much monitoring, perhaps if you're getting too many alerts, humans tend to start, ignoring them in a way that's bad too. And it's a dangerous problem. We do it at our own risk because if I ignore issues that are happening, then I can have preventable outages, which is never a good idea, right? But on the positive side, we have far better tools at our disposal. Just think about the tools I mentioned in this talk, PagerDuty, Slack, SignalFx, Lambdas. None of them were even there like 10 years back, right? So we have like very, very good innovation going on where the kind of tools that we have at our disposal are very, very powerful. And so that gives us hope that maybe something can be done about it. And what's good about these tools, the reason I consider them good and powerful is that they are generic platforms. They are not niche solutions. Like PagerDuty can be used for so many different use cases. Similarly, metrics does not have to be metrics about compute. I can have metrics about from business metrics or social metrics, as I talked about. These are generic platforms that are usable for many different use cases. And the last one is obvious. The whole is greater than sum of the parts, or the whole is greater than the sum of the parts, because by combining these tools together, you can actually achieve greater value, right? And easily. This is really the fascinating part about it. For example, this whole example of that Lambda and Slack metrics and whatnot, it actually just took me 2 hours to set it up. The reason is all of the systems were in place. We had a metric system, we had PagerDuty, we had alerting, we had Slack and the API. So writing something like this is not really about the technical complexity. It's about sort of, again, thinking outside the box and building it. And that gets us wondering, like, what else is out there in terms of signals for us to exploit, right? Initially, though, frankly, like I was initially a little bit disappointed that I could not create the perfect alert based on the application and infrastructure metrics. We are a metrics platform. We provide monitoring. It felt like that should have been tractable, right? But in hindsight, it feels like maybe that was a naive assumption on my part, right? Because frankly, when a system gets at some point beyond certain level of complexity, you have to sort of start using other means. And much of the conference, much of the discussions from PagerDuty announcements are about that. Like, how can I make sense of complexity, so to speak? So maybe it's not that bad, right? Social signals can be a very useful source of data for us. And in this case, the previous talk, or one of the previous talks mentioned about Slack as a system of record. So when you're doing like a post-mortem, that's where you go to see what happened, what time did something happen. In this case, it's not that. That's after the fact. Here we are actually using it to drive monitoring and to alert me. And that can also be a legitimate use case, right? There are many companies that actually use Twitter, which is another source of social signals, to monitor their site. Because if you're a popular consumer site and things are wrong, well, if users are having issues, they're going to let their IR be known. And then you could use that as a way to sort of independently validate or even get alerted when something's off, right? Or you could look at the number of tickets opened or status page visits or whatnot. So there are many signals for us to look at. Other signals are also possible. I don't know. I put IoT in there to look smart. But in general, like if I'm a FedEx and if I'm doing some kind of business metrics, I'm doing some alerting, maybe weather matters. North Carolina's going to have a hurricane. Maybe website visits from there are going to go down. So there are potentially different ways, or at least whether we use them for alerting or as additional context for us to inform ourselves about what's going on. The point is, again, let us not just confine ourselves to sort of the usuals and sort of, again, think through and see what else is out there for us. We have very, very good tools out there, so they can be used for those purposes, right? That's my talk. I'll take any questions if there are any. Yes?
What you described, taking executive soup to a nightmare level, essentially?
Why do you ask that?
Because you're essentially, what you're doing is you're looking for human activity in your incident channel and then swooping in, right? You're getting a
yes.
Right? That's what I'm saying.
Yes.
That's what I'm saying.
Yes. Yes. So in my case, it's relevant because I have built many of these systems. So the reason I want to get involved is because I want to help, not necessarily insert myself. So this was done in a passive way where engineers were not disturbed in the production of this alert, for example. It's just something that I wrote that's running on the side. And secondly, again, it gives me a chance to go and either help with the decision making or with the technical due diligence to figure out like what the problem might be. Now that may or may not be valid for, let's say, our CEO who's not obviously as technical or not as involved, but in my case it does make sense, right? And so again, this is just an example, but the idea is these signals are out there, right? And frankly, like I actually have contributed a few times because of getting alerted and so on. So it's not, because where the engineers have it covered, they're going to figure it out. But again, having me involved in some cases may be helpful, right? There was another question?
So
yes.
This ability to call it
That is exactly right. So I bolted things together. So as I mentioned, these services, all of them have now APIs. They're very easy to work with. So Slack has APIs where you can just go and make calls and say, fetch me all messages, fetch me all users. Users can be classified. So what I did was I knew which are the ones that are coming from our alerting system or from PagerDuty. I classified them as bots. The other ones I knew which human it was. So it's very, very easy to just get a few messages and classify them in a Lambda, in which case. So there was no custom much. Like if I shared the code for the Lambda that did this, you will be surprised. It's like one screen or less. So it's actually quite out of the box in that sense. Right. Anything else? All right, that's my talk. Thank you very much for coming.